Well, welcome to our video here on special types of linear systems. We have worked with linear systems in some previous videos. We solved linear systems by graphing. We solved linear systems by using the substitution method, and we also solved linear systems by linear combinations. And in this video, we're going to talk about the special types of linear systems. We're going to talk about three types of linear systems here. And in this first example, if you look, you have two equations on this coordinate plane here. And these two equations intersect at that ordered pair, which is 1, 1. And so this type of linear system has one solution to it because those two lines cross once. Well, if we look at the next type of linear system that we're going to talk about, these lines here, these linear equations, are they ever going to intersect? Well, if we look at them on the graph, it doesn't look like they're going to intersect. But when we talk about parallel lines, because that would mean that these two lines don't intersect, when we talk about parallel lines, we have to look at their slope to actually prove that they are not going to be intersecting at any point. So I have 2 points. On the yellow line, I have 2 points plotted. So let's find the change in y. The change in y over the change in x. Most of you think of this as rise over run, but the change in the y values, we've gone up 2, so that's a positive 2. And change in the x, how far left do we go? Well, left 1 is a negative 1. Negative 2 is that slope. Well, let's look at the other line. The other line, it crosses right there at negative 2, 0, and negative 1, negative 2. Change in y over the change in x. Change in y is a positive 2 over the change in x, so that's left 1, negative 2. And if we look at the slopes, negative 2 for both of them. So we know that those two lines are going to be parallel because they have the same slopes, and therefore they will never intersect. And we say for this type of linear system, there is no solution. There's no solution for this type of linear system. Now, this is how you can look at a graph and identify that there's no solution. But we're going to talk about how you can look at some problems, and when you work those out by either substitution method or linear combinations, when you work those out, you'll be able to identify whether they are parallel or not. Well, let's look at the last type. You may only see one line here, but look at the ends. The ends here are orange. And that's because the yellow line is sitting on top of the orange line. And we know that the yellow line has arrows on both ends, so it extends forever in both directions. And the orange line also has the arrows, so it also extends in both directions forever. And so when we look at this, these lines are exactly the same line. They share this point, and this point, and this point, and they share all of these points. And if we look, they also share these other little points. And you see I'm putting those in between, but now I'm going to put more in between those. And if you notice, if I keep putting these points, I can keep putting points there. And the solution for this one is infinitely many solutions. Infinitely many solutions. And so therefore that means that those two lines, that system of linear inequations, they touch at every single point infinitely many times because those arrows keep going on and on forever. All right, how do I identify these? Okay, well, let's look at this. Let's look at this linear system that we have here. How are we going to be able to identify this? Well, I'm looking here. I'm thinking that we can go ahead and use linear combinations to solve this. I know that if I multiply that 2 by -3, I don't want to multiply it by -3. I want to multiply it by +3 because this 6 down here is already negative. Let's multiply it by +3, and then that will be the opposite of that -6. So 3 times 2x, it's 6x. 3 times 1y, it's 3y. And 3 times 5 is 15. And on the bottom equation will stay the same. And so now that we have the numbers in front of the x's that are opposite of each other, we'll go ahead and add 6x plus -6x is going to be 0x, which is just 0. Let's add the y's together. 3y plus -3y is also going to be 0y, which is just 0. Bring down our equal sign. And 15 plus -15 is 0. So work out the left side. 0 plus 0 is 0. So this is what we have. 0 is equal to 0. Well, if 0 is equal to 0, that is true. That's true. So that means that if we look, the top equation and the bottom equation are the same exact equations. And when that down here, 0 is equal to 0, when you have a number is equal to a number, like you could have had 5 is equal to 5, or you could have had -3 is equal to -3. All of these are true statements. There's no variables left in there. So therefore, the statements themselves are true statements. And if they are true statements, you know that those two lines are exactly the same. And your answer, infinitely many solutions. Infinitely many solutions is what you should have there. So we just use linear combinations to figure this out. We didn't have to graph it or anything. We just used linear combinations. Let's look at this other one here. Well, this next system of linear equations, I'm trying to figure out if I can get the cancel off the x's, cancel off the y's. And it's not possible for me to multiply one equation to make an opposite coefficient, so that way we can cancel off a variable. So what I'm thinking is we're going to have to multiply both equations. I don't want to use, actually I can use 9 and 6. 9 and 6, we're going to take those to 18. We're going to take those to 18. So what number do I have to multiply 9 by to get 18? That's a 2. What number do I have to multiply 6 by to get 18? That's going to be a 3. Now if you notice, the 9 is negative along with the 6. It's also negative. So we have to make one of them a positive in order to have those coefficients. We have to make one of these coefficients to be positive, and in order to do that, you multiply it by -3, or you could have multiplied by -2, and then the bottom one would have been multiplied by a +3. But in this case, we're going to multiply like we have it here. 2 times -9x is -18x. 2 times 3y, 6y. 2 times 12, 24. And on the bottom, we're multiplying by -3. So -3 times -6x is 18x. -3 times 2y is -6y. And -3 times 4 is -12. well, now we have, if we look here in front of the x's, we have opposite coefficients. So let's go ahead and add those. Negative 18x. Negative 18x plus 18x will give you 0x. 6y plus negative 6y will give you 0y. They're canceling out here. You know, on the left side we have 0 because this is 0 plus 0, which is just 0. And on the right side, 24 plus negative 12 is going to give you 12. So 0 is equal to 12. And everybody knows that 0 is not equal to 12. But when we use linear combinations to work this out, this is what we're getting, which is a false statement. 0 is not equal to 12. So if this is a false statement, what we're going to do is we're going to say that this linear system has no solutions. And do you remember what type of lines have no solutions for a linear system? Those would be parallel lines. Parallel lines will never intersect, so we have no solutions there. So, any thoughts or questions there? Remember, if you have any questions, make sure you put a question mark on the left side of your page and note the time. That way when I see you next, or you can send me an email. For those of you that I don't see, you can send me an email and I can try and get that explained for you. In this last linear system, let's go ahead and solve it out. Let's see if you can go ahead and solve it out. You go ahead and solve it out on your own, and then identify whether it has no solutions, infinitely many solutions, or maybe it might even have one solution. You can use the substitution method, which would probably be the easiest way here, or you can use linear combinations. I'm going to do it using substitutions. So go ahead and pause the video, work it out, and then check your solution with mine. Okay, if we look here at the top equation, it says y is equal to something. So I'm going to plug what y is equal to from the top equation right in there for y. And that would be negative 2x plus 7. So we have 3x minus, don't forget your minus sign outside. And what does y equal? Well, y is going to be equal to negative 2x plus 7. We get that from the top equation. And that's all equal to negative 2. We have a negative sign outside, so it's like a negative 1 out there. We take negative 1 and multiply it by everything inside the parentheses. So negative 1 times negative 2x is a positive 2x. Negative 1 times 7 is a negative 7. Okay, that's where we're at. So 3x plus 2x, combining like terms, we're going to get 5x minus 7 is equal to negative 2. And in order to solve for x, we're going to add 7 to both sides. 5x is equal to negative 2 plus 7 is going to be 5. So then you divide both sides by 5. And x is equal to 1. So what we're going to do is we're going to take that, x is equal to 1, and we're going to plug it right in here for x. So we know y is equal to negative 2 times x, which is 1. We found that to be 1. Plus 7. Y is equal to negative 2 plus 7, and then y is equal to 5. We are close to being done. We need to put our answer in an ordered pair. X is 1, y is 5. And this is what we have. 1, 5. So those two equations that we started out with at the very beginning, these two equations are going to intersect at the point 1, 5. They have one solution. Okay, well, that is all we have for this video. I hope it helps you out, and we will see you next time.